Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're talking about this question of, is there a new proof of the Pythagorean Theorem, or why would it matter? Some things like that there. Now, inspiration for this is some headlines that have been popping up in the past few weeks there. Stuff like here, just looking at some Google search results, US teens say they have a new proof for a 2,000-year-old theorem, right? Some were even much worse than this. There was a lot of clickbait. A lot of these, I think, has been updated, right? New Orleans students prove 2,000-year-old math theory, things like that as well. Now, the theorem that they're talking about here, spoilers, has been proven for years that way, right, is the Pythagorean theorem, right? If we have a triangle, in particular, if we have a right triangle, we have two of the side lengths, and then of course we have our hypotenuse there as well. We have this very elementary relationship between those side lengths and the hypotenuse, right? Most students are very comfortable with this, right? Even a lot of adults, even if you don't remember much math, this is a piece of information that a lot of people are fairly comfortable with there as well. So this is the Pythagorean theorem. Now, this is a very old theorem, right? You can talk about different timings of stuff like that there, right? It's probably even known as far back as the 20th century BC, right? So this is a very old theorem there, right? Not necessarily proofs going back there, right? There's a kind of long history of people knowing this, right? Being able to see different examples of this. That's different than the full result being talked about or known, things like that there, right? It's named after the Greek philosopher or mathematician, however you want to think about it, Pythagoras. It's proved in Euclid's Elements. Euclid's Elements is oftentimes thought of as the basis for modern geometry. It's one of the basic things that is proved in that book, in that manuscript there. So it's not something that is unproven, things like that there. So where does this idea of new come from, right? There have been books written on this, right? It's history, right? Different things like that there as well, right? 4,000-year history, 24 proofs in this book. These books are more recent, in the 2000s, 2010s, that region of time. But let's go back to a much older book. This book called the Pythagorean Proposition. This was written in 1927 or published in 1927. Whole book again written on proofs of the Pythagorean theorem and talking about these proofs by a mathematician, Elisha Loomis, there as well. And this book is the reason for some of this ideas of new proofs and things like that there. So let's take a look at this new abstract, or at least a part of this abstract there. This abstract was presented last month, or sorry, this presentation took place last month there by kind of two actually high school students. So that's where this is a little bit fun and interesting there as well, right? So these two young women, Jackson and Johnson, are both high school students, I think seniors in high school, and they presented this at the AMS sectional meeting in the Southeastern section last month. And, right, the key quote from this book, right? So where does this book come in and where does this history stuff come in there, right? So in this Pythagorean proposition, right, Loomis states that there are no trigonometric proofs. because the fundamental formula of trigonometry are based on the truth of the Pythagorean theorem. I'll say a little bit more when we get to that type of stuff there. But right, I want to talk a little bit here about what we might mean by kind of depending on other facts, or this idea that I want to introduce today that some people might be comfortable with is this idea of circular reason. So let's talk a second here. Quick example, we have some old Thursday Tidbit videos if you want to check out old playlists proving these things, talking about these things in more detail. But what is the law of cosines there? So law of cosines, let me just abbreviate that LOC in this scenario. Here we have a more general triangle. So we don't necessarily have a right triangle here. It's not a equilateral triangle or anything in that scenario. And let's say we have sides A, B, and C. And we need an angle for this there. So if we think of this diagram that we have set up here, right, what is the statement of the law of cosines there? So law of cosines states, well, and this should remind us quite a bit of the Pythagorean theorem, right? So we have c squared is a squared plus b squared. So we start out exactly the same in that scenario. But now we have minus 2ab and we have cosine of theta. So we have this angle there, cosine of theta, and we need to subtract some of that off from the a squared plus b squared in this case. Now, very, very easily here, and there's a couple of things that we can do with this, right? What happens in a right triangle? Well, what does it mean to be a right triangle, right? How could we make this look like Pythagorean theorem? Well, what happens if theta is 90 degrees? Right, then cosine of theta is cosine of 90. This is 0. So in that case, in this specific case, in this special case, well, where theta equals 90, our law of cosines for that angle, right, states exactly the Pythagorean theorem. A squared plus b squared minus 0. And so this gives us exactly what we want in terms of the Pythagorean theorem there. So everything works out very, very easily in this scenario. Now, the question here becomes, right, well, where does this title, circular reasoning, come from? Right, here we have a very simple proof of the Pythagorean theorem. It's using trigonometry, right? This is something almost every class probably even teaches you. When you learn about the law of cosines, you talk about how it relates to the Pythagorean theorem. So where does this idea of circular reasoning come in? Well, let's get to our first question that I want you to look at for next week's video. That is, right, use the Pythagorean theorem and basic right triangle trigonometry to prove the law of cosines. And the key here is, right, this is the standard way you prove the law of cosines. You use the Pythagorean theorem to prove the law of cosines. So, right, we could have kind of this picture going on in that scenario, right? Where does this circular stuff come in, right? Well, if you use the Pythagorean theorem to prove the law of cosines, you can't go back and prove the Pythagorean theorem using the law of cosines, right? You then again end up in this circle where you're just assuming what you're trying to prove. So show that this direction, right? Show that proving the law of cosines using the Pythagorean theorem is okay. What do I mean by that, right? You want to think about at least. You don't need to worry about this too much, but just make sure, right, you're not assuming anything that you can't. You're not using more advanced things to prove simpler things there. That's the crux of this argument as well. Now, want to ask this question too. Is this the first trig proof, right? This Loomis book was 1927, made this claim a long time ago. This isn't quite the first time this type of thing has been thought about. Still pretty recent. Actually, in a 2009 paper, Jason Zimba gives a proof using trigonometry and proving the Pythagorean theorem. Now, his proof is based on the cosine difference formula. So that formula says if you want to calculate cosine of A minus B, you can do that in terms of cosine of A and B and sine of A and B. So that's this idea there. As my second question to challenge you for next video, right, use that formula to prove that for an angle x, with x between 0 and 90 degrees, cosine squared of x plus sine squared of x equals 1. And, right, you can use this then to prove the Pythagorean theorem there, right? And that's kind of the important thing you want to think about here. Now, further, think about why we actually need to be careful to ensure that there is no circular reasoning in this case. We'll talk a little bit about this in next week's video, but try to think about that here. And this portion is important. It's important that we're dealing with angles between 0 and 90 degrees. First of all, note that's all we need to prove the Pythagorean theorem, right? Because if you think of a right triangle, I'm not going to label the sides, even that's as maybe a little bit of a hint in this case there, right? But if you think about that and then think about an angle, if we think about this angle being x, then of course, if we have it in a right triangle, x is between 0 and 90. So that part is okay. But think a little bit about why then using these acute x is important. Why might we need to be careful with the cosine difference formula? If you know a little bit about trig identities, there is a reason I'm talking about the cosine difference formula and not the addition formula here as well. All of those things are stuff you can think about there as well. Now, ending the video here, I want to just point out that even if they weren't the first people to present this idea of a trigonometric proof of the Pythagorean theorem, and right, their full presentation isn't even available yet there, they do have some cool ideas. I'm going to link a video below of another video of a person who was supposedly at their presentation during the conference and gave their interpretation of what they thought the proof was, right? So hearsay stuff there, but it's an interesting idea there as well. And I just want to take a moment to say these ideas are cool, especially from the fact that they were thought of by high school students, right? And so I just want to say, if you're watching this video, if you're a student, right, high school, college, right, even if you're an adult watching this, right, just because something is known doesn't mean it's not useful or helpful or interesting to try to think about it yourself. Can I prove this? How might I prove this? Maybe you need some hints, but it still can be interesting to think about stuff that way as well. Okay, that will do it for this week's video. Try to think about the two questions I posed here. We'll talk more about those in the continuation next week. Let us know if you have any thoughts for what to cover next, or thoughts about this new proof of the Pythagorean theorem in the comments below. Subscribe for all of the updates. Otherwise, thanks for watching. I'll see you all next week. Goodbye.